In this video, I want to have a look at finding the distance between 2 points. So to be able to find the distance, we're actually going to use Pythagoras' theorem. So hopefully you remember Pythagoras' theorem is c squared equals a squared plus b squared, where c is the hypotenuse of our triangle and a and b are our two shorter sides. So just to jog your memory of Pythagoras' theorem and how it works, we're going to have a go at one example. So this one here, we've got our sides 28 and 21, and we're trying to find the length of that diagonal. So if we call that, for example, x, then we would have x squared equals 28 squared plus 21 squared. And it doesn't matter if we had those in the other order. If we had 21 squared plus 28 squared, it'll give us the same thing. So then 28 squared plus 21 squared is 1,225. But that's x squared, and we just want x. So we're going to take the square root of both sides. And we'll end up with, so if we go square root of that answer that we just had, we'll end up with 35. So that means that that hypotenuse is 35 units long. All right, I'm going to let you do the other two on your own. But we're going to have a look now at how that can help us when we're finding the distance between 2 points on our number plane. So to find the length of an interval, we're going to create a right-angled triangle. So once we have that right-angled triangle, we can then use Pythagoras' theorem to find the length of the interval. So let's have a look at an example. So in our number plane here, we have the points A and B. So we're trying to find the distance between those 2 points. So what we've done, and this one's already done it for you, from the taller point, whichever one's higher up, we've dropped a line straight down until it's level with our lower point. So we've dropped that line straight down there. Then we've joined it up with a horizontal line across to our lower point. Once we have that right-angled triangle drawn in, we can calculate those lengths of those two shorter sides. So this one here, you can see that it's 4 units long. It's four boxes long, 4 units long. And this one's 3 units long. Now, if we weren't given that, or if we didn't have our grid drawn, we could figure it out because we know that this point here has a y-coordinate of 2, and this one up here has a y-coordinate of 6. So that means we've moved up 4 units. We do the same with the x's. This one has an x-coordinate of 1, and this one has an x-coordinate of 4. So that means we've moved across 3 units. So now that we've got our right-angled triangle, we can write that AB squared, so that's our hypotenuse squared, is equal to 4 squared plus 3 squared. So that would give us 25 if we popped it in a calculator, or you can figure it out without one, which means that AB has to be the square root of 25, which is 5 units. Right, so that's an introduction to finding the distance between 2 points.